For page 24, you will cut out the half sheet of paper I gave you earlier today, and you will paste it toward the top, which means you will no longer need a title page. And so tomorrow in class, we're going to be talking about completing the square. This is an Algebra 1 standard, so you will remember how to do this partially, but it's a pretty difficult standard. It's actually more difficult than factoring. So I'm going to spend 2 days on this so that way we can have plenty of practice. And so the example that we have here, we are going to be solving a quadratic equation by completing the square. The example we're given is to solve that 3x squared minus 18x plus 6 is equal to 0. You could very easily solve this by factoring. You could pull out a 3 as a GCF and then solve the inside of that with the cross method or tic-tac-toe, whatever you choose to use. That would work here. But we're going to solve this one by completing the square. And so we're going to have these 6 steps that we're going to follow. And so it says that remember a must be equal to 1 to use this method. So if you have any other number besides a equals 1 here, you need to divide everything out in order to get a 1. Now technically I would divide by 3 on all of the terms, and this 0 being included. I didn't do it here because 0 divided by 3 is still 0, but if this was any other number like 4 or 7 or 9, you would have to divide this by 3 as well. So when I do that, I'll divide each term by 3, and I end up with this now. This will be my new A, my new B, and my new C. It says to isolate the x squared plus bx to one side of the equal sign and the constant on the other side. So now that plus 2, which was my c, will move to the other side through subtraction, and I have x squared minus 6x equals negative 2. Step 3, we're going to take half of the coefficient b. This is the one in front of the bx term. When I do that, I'm going to get 6 divided by 2, which is going to be 3. Step 4 says to square the result and add it to both sides of the equation. Remember, whatever you do to one side of an equation, you must do to the second side as well. So we're going to have plus b over 2 squared, which in this case is plus 6 over 2 squared. And we're going to add that to both sides of my equation. That turns out to be plus 3 squared, which is the same thing as plusing 9 on both sides. So we now have x squared minus 6x plus 9 equal to 7. We're now ready to do step 5. It says to create a perfect square. So from here, I would factor this. This becomes x minus 3 times x minus 3, which is the same thing as x minus 3 squared. You can skip these 2 steps here in the middle. If you can go straight to these, I have no problem with that. I just wanted to show you where they got this from. Okay? Whenever you're doing your completing the square and you're factoring, whatever your b was will always be the second part of your binomial. Whatever the middle sign is for your b is always also going to be the operation that you would use here. And then you would always have x going to be here. If you do not have that, you've done something wrong and you need to redo the problem, or redo that step at least. Step 6, this now looks like a problem we would have done in the PowerPoint that involves solving quadratic equations by taking square roots. At this point, we would take the square root of both sides. We would have a plus or minus root 7 on the right, and then x minus 3 on the left. You would add 3 to both sides, and you would get x equal to 3 plus or minus root 7. So that's the example that they've provided. We're going to do 2 additional examples. The directions are the same. We're going to solve by completing the square. So the first example that we have looks like this. I do break this up into its different steps so that you can see along the way what we're doing. And so example 1, we're going to be solving negative 2x squared minus 2x plus 1 equal to 0. Because a is negative 2 in this particular case, we do have to divide every single term by negative 2 so that we can complete step 1 and get a to be equal to 1. So step 1 will now look like this, and we now have this. Step 2 says to move the new c term to the opposite side, so we'll add that 1/2 on both sides, and so we now have the x squared plus x equal to 1/2 for step 2. For step 3, it says to take half of b. In this case, b is equal to 1, so half of that is going to be 1/2. Step 4 says to add the square of that to both sides. So we're going to add 1/2 squared to both sides of my equal sign. So I have x squared plus x plus 1/2 squared equal to 1/2 plus 1/2 squared. That's going to become 1/4, so I just went ahead and did on the next step, simplified that. On the right side, in order to add 1/2 to 1/4, I need a common denominator, so I made that 2/4, and 2/4 plus 1/4 is now 3/4. On step 5, it says to factor this, creating a perfect square. So if I were to factor this into its perfect squares, please remember I said that whatever b was would go on the right-hand side of the binomial, and whatever the sign was for your b would go as your sign in the middle of your binomial, and then x would always be at the beginning. So we have x plus 1/2 all squared. If you were to FOIL this out, you would truly get x squared plus x plus 1/4. You can try that if you don't believe me. And on the right side, 2/4 plus 1/4 is 3/4. At this point, this now turns into a problem you can solve by taking square roots. That was a lesson that we learned prior to this one. So we would take the square root of both sides. Don't forget your plus or minus symbol. And so now you have this. Remember, when you take the square root of a fraction, you take the square root of the top and the square root of the bottom. So the square root of 3 would remain at the top, and then divided by the square root of 4 would come down to the bottom and become 2. I'll move that plus or minus to the other side, and so I have x plus 1/2 equal to plus or minus root 3 over 2. Then I'm going to solve for my x by subtracting the 1/2 on both sides, and so now I'm going to have negative 1/2 plus or minus root 3 over 2, and then if you want, you can just simply combine those denominators since they already have a common denominator and write this as negative 1 plus or minus root 3 over 2. Example 1 is now complete, so we'll now look at example 2. All right. For example 2, you'll notice you have x squared equal to 3/2x minus 1/2. Your a here is already 1, so you don't need to divide by anything, so we're going to not have to complete step 1. Step 2, however, you're supposed to have your x and your your x squared and your bx term on the same side and your constant on the opposite side. So I actually need to move that 3/2 x to the left side along with the x squared. So now I'm going to have x squared minus 3/2 x equals negative 1/2. You're now ready to complete step 3, which is to take half of b. b in this case is negative 3/2. Half of that is going to be negative 3/4. I'm just going to multiply 1/2 times negative 3/2, and that becomes negative 3/4. So now in order to do step 4, you are going to add the square of half of b on both sides. So we have x squared minus 3/2 x plus parenthesis negative 3/4 squared, and you'll do that on the left side and the right side of the equal sign. That becomes 9/16 when you square that. We're now ready to do step 4. Oh, nope, just not. Oh, this said we are on step 4. I went ahead and got a common denominator for my right side so that I can add my negative 1/2 and my 9/16 together. Negative 1/2 is the same thing as negative 8/16. So I'm going to add those to get a 1/16. We're now ready to do step 5, which is to factor this into a perfect square. Half of b was 3/4, so I know that's going to be the right side of my binomial. I'm going to have x on the left side, and the sign of b in this case was negative 3/2, or negative, so I'm going to put a minus in between. So I get x minus 3/4, and I'll square all of that. If you FOIL this out, you will get this trinomial right above it, because this is a perfect square trinomial, and it becomes a binomial squared. At this point on step 6, you would go ahead and solve. You would take the square root of both sides. The square root of 1/16 becomes plus or minus 1/4. And then you have x minus 3/4 on the right. You would add 3/4 to the right side, so you would end up with 3/4 plus 1/4 and 3/4 minus 1/4. So we end up with 4/4 and 2/4, so our final answers are 1/2 and 1. Okay? So if you were to do either one of these problems by factoring, you could possibly do it and get these same answers. This is especially true in example 2. It would work out for you. On example 1, it actually would not work out. If you tried to do this one by factoring, it wouldn't work because this is a prime polynomial, and so you would have to complete this by you would have to solve this by completing the square.